Welcome back. If you just finished up Linear Inequalities Part 1, we left off with graphing linear inequalities, very straightforward ones. So I wanted to pick up at Part 2 with a little mental math note, just so that we can make sure we're reinforcing that concept that we will use an open dot when we have the greater than or less than signs. This conveys that the number is not included in the solution. We will use the closed dot. And remember, this is only when we're graphing things, right? So you see in checkpoint 5, we're graphing things. When we have the, oh boy, let's erase those, make them a little bit clearer. One more try. We'll make it down here. Note to self. Apple Pen would probably work better, but this gets the job done, right? So when we have the greater than or equal to or less than or equal to, this conveys that the number is included in the solution. Let me see if I can type in some math text for you. Let's go with symbols. There we are. So it's a little bit better. That way I can go to sleep at night with the quality of this video. Okay. So once again, if we have the equal sign underneath the inequality, right, that little dash, right, kind of almost half of an equal sign, we want to use a closed dot to indicate that the number is included in the solution. Okay, I'm going to do one piece of checkpoint 4 and one piece of checkpoint 5 before moving on to the nitty-gritty, which is solving these linear inequalities. So if we wanted to graph, we obviously would need a number line. I should have probably included one, but this pen isn't letting me down. If you want to create, your tick marks, feel free, but as long as I know that we're basing it around 2, right? I want all of the values of A such that 2 is greater than or equal to A, okay? So like I said before in the previous video, we have to be careful here because it's not written in the most traditional manner, where we typically have the variable on the left side of an inequality or an equation. So start substituting in numbers, right? If we were to pick 3 as a value for A, we ask ourselves, is 2 greater than or equal to 3? It's not, okay? 3 is on that side of the inequality where I just placed the dot, okay? If we ran that same process with 4, 2 is greater than or equal to 4, once again, not true, also on this side. So we're starting to see a trend that all the values on the right side, right, or that are greater than 2 are not the solutions. In fact, the solutions are all the values that are, oh wow, there we go, much better. I'll get the hang of this one day. Right, all the values are actually the values that are less than 2. And let's just select one, a value less than 2, 0. 2 is greater than or equal to 0. That is true. Right, sometimes just kind of thinking through our little workflows. And let's pick D for my last name. Okay. First couple of things I notice are we have an arrow extending in the right direction, meaning indicating larger values. So I want to have the greater symbol. Okay. I notice that's closed dot. So I also want to have the equal to. Okay. I know 0 is our starting value, and I know that the variable needs to be larger than 0. And that's it, okay? And you can more or less apply that same type of thinking or ideology to the other 3. As you see, one has a similar structure, and the other 2 are extending in the opposite direction. Okay. Like I was stating, I can't remember if it was earlier in this video or in the previous video, but contrary to linear equations that only have one solution. A linear inequality has what we call a solution set. That is a set of all numbers that makes the inequality a true statement. Man, that E is rough. All right, the awesome connection, however, between linear equations and linear inequalities is that the method that we use to solve the two types are identical, with one catch, right? And you're probably sitting at home, as an adult, and you're like, this was always the deal with math, right? It was always, oh, but don't forget about this. Oh, but don't forget about that. Okay. The one catch is when multiplying or dividing by a negative value, as you solve a linear inequality, you have to, I like to use the word switch. If you're currently enrolled in some adult learning courses, they might use the word flip, they might use the word alter, they might use the change. They're all the same. Let's take a look at one in depth. Okay. Let's see. I gave you a few here to practice. I gave you 8, so I'll do 2 of them. That seems like a pretty fair trade-off. All right. And in the process, we're going to wind up refreshing how to solve a linear equation. So it's a win-win. Okay. Let's take a look at E. Right, so back in our linear equations videos, right, we see a set of parentheses, so that's kind of our roadmap, right? We want to alleviate ourselves of any grouping symbols, so we would use the distributive property here. 3 times t is 3t, and 3 times a positive 1 would yield me a 3 minus 4t is greater than or equal to -5. Okay. Before I continue, I take a look at the left side of the equation or the inequality. I see that there are like terms with our 3t and minus 4t. Notice I use a single underline rationale. You get to the end of an equation or an inequality on your test, and you look down at the answer choices, and the value that you have doesn't coincide with the values you see before you. Okay? You can now quickly glance back and specifically locate what terms you combined, so on and so forth. Okay? Test anxiety happens. You might have made a mistake. It's okay. So 3t minus 4t is going to yield a negative t. That is atrocious. And if you know me personally, you know I take a great deal of pride in my writing. Negative t, right? We did not touch or do anything with the plus 3. It's greater than or equal to -5. Now, remember, now we take a look. We see there are no like terms on the left side. There is only a numerical value, which we call a constant, on the right side of the inequality. So we would want to take the numerical value from the left and move it to the right. Remember, anytime we decide to come across an inequality symbol or an equation or an equal sign, you must perform the opposite. -5 minus 3 is -8, and we're very close. But just like our equations, right, where we want the final solution to be a positive variable, x, y, t, whatever the case may be, right? We don't want a coefficient in front. We don't want a negative value. So in order to alleviate ourselves of this, it's a very simple step that most will forget. But remember, we have a imaginary -1 right there. So we would want to divide by -1. Since these two pieces are being multiplied together, -1 divided by -1 will yield a positive t. But in doing so, and I'm going to highlight this in blue, we need to alter the direction of our inequality symbol. Okay. If you do not, you will not have a complete solution. And you do not want to be the person that does everything correct, and then the final step is where you make an erroneous error. Okay, let's do one more before we decide to wrap up this video and you get into the nitty gritty on your separate sheet of paper and start hammering these out. Let's look at, oh, I just noticed that I have two of the same ones on here, G and D. That's all right, double the practice. Let's see if we have a better one up top. Yes, let's take a look at B. Okay. So now, very similar start. We have grouping symbols, distributive property to the max. 4 times x will yield a 4x, and 4 times the second term, 3 will yield a 12. 2x minus 26. If you're one of my adult students, you know that this is a windshield wiper situation, right? We have 4 options. We're going to go in one direction with one term, and we're going to return in the opposite direction with a different term, just like your windshield wiper does. Okay? So I'll start with the variable. Personal preference, if you've watched the linear equations videos, is that I like to make sure that my variables are on the left side of the equation. That's just me. You are more than welcome to do as you please, but I'm going to take this 2x and subtract it because it is currently positive from the 4x. I'm making sure I do things on both sides of the inequality. 4x minus 2x will yield a 2x. Okay. And to save space, I am going to apply, so I've gone in this direction with the variable, so I'm going to return just like your windshield wiper. So if the 12 is positive, I'm going to subtract it. And I know that might be overwhelming for many of you that like to do things in a very sequential pattern, but efficiency is key, right? That time is ticking, and you don't want to continue to have to do everything on a step-by-step basis. Okay, it's perfectly okay to combine 2 steps into one. It's uncomfortable at first, but I'm confident in your abilities. Right, so is less than negative 38. All right, okay. And to conclude, right, we have our variable, which is being multiplied by 2, so I would want to divide by 2. And x will remain less than negative 19. Now, you might be sitting there wondering, but Joe, didn't you say that we have to flip the inequality symbol when we have a negative? No, that's actually not what I said. Right? I said when multiplying or dividing by a negative, right? That's 2 different types of sentences, okay? Just because we have a negative, right? We had a negative 38, but that was not what we were multiplying or dividing by, okay? It's whatever is doing the operation. So in this instance, we were dividing by a positive 2. So we don't want to alter the inequality symbol. Whereas in this example, we were dividing, this was originally a negative, but we were dividing by a negative 1. Okay, so it has nothing to do with what value is being divided or being multiplied, and everything to do with what value is doing the division or is doing the multiplication. Okay? Thanks for joining. Stay tuned. Get some of those practice problems in, and I'll see you in part 3.